Hello, my students. Now we will continue the first lesson in primary 6, which is mass and weight. In the last session, we talked about mass and we talked about the definition of mass, properties of mass, measuring units of mass, and finally, the measuring devices of mass. Now we will talk about the weight. Some students will tell me, Miss, the weight equal the mass. The two definitions are the same. I will tell you, of course, no. The two definitions are completely different from each other because the definition of mass is completely different from the definition of weight. Why? Because the weight means gravitational force of Earth. Weight equal gravitational force. Don't forget it. Weight means gravitational force. If I ask you what is meant by weight, you will tell me it is the force by which a body is attracted to Earth. It is the force or it is the gravitational force by which a body is attracted to Earth. Excellent. So weight is completely different from mass. In the space, there is no weightlessness, because there is no gravity. The effect of the weight is directed towards the center of the Earth. Of course, the weight is directly towards the center of the Earth. Why? Because weight means gravitational force. Don't forget, weight means gravitational force. Now, if I ask you, how can we measure the weight? We can measure the weight by this device, which is called the spring scale. Which is called what? Spring scale. And the measuring unit of weight is Newton. Can you tell me what is the measuring unit of mass? Excellent, I can hear you. Excellent. Gram and kilogram. Gram and kilogram. What about weight? The measuring unit of weight is Newton. Excellent, Newton. If I ask you what is meant by Newton, you will tell me Newton is the measuring unit of weight. Excellent, which is almost equal to the weight of an object on the Earth's surface whose mass is 100 gram. Whose mass is 100 gram. This point is very, very important. This means that if the weight of the object equal 1 Newton, so its mass equal 100 gram. If I give you a ball and if I tell you that this ball, its weight is 100 Newton, so you will know that, so its mass is 100 gram. If the weight of the object 1 Newton, so its mass 100 gram. Now we'll talk about the factors affecting weight. Factors affecting weight. What's meant by factors? Factors means they are things affecting weight. This means that by increasing them, the weight will increase or decrease. Okay, such as the first factor is called mass. By increasing the mass, the weight will increase. Of course, the mass is affecting the weight. How? By increasing the mass, the weight will increase. The weight will increase. Number 2, the planet. Number 2, the planet. Of course, by increasing the mass of planet, such as if I travel to the moon, my weight will decrease. Why? Because the mass of moon is very, very small related to the mass of Earth. So by increasing the mass of the planet, its gravitational force or its weight will increase and the weight of object on it will increase. So my weight on Earth is more than my weight on moon. Why? Because the mass of Earth is more than the mass of moon. The third factor is called the distance between the object and the center of the planet. If the distance between the object and the center of the planet increases, so the weight will decrease. the weight will decrease. By increasing the distance from the center of the earth, the gravitational force will decrease and the weight will decrease. So we have three factors. The first one, mass. By increasing the mass, the weight will increase. Excellent. Number two, the planet. By increasing the mass of the planet, the weight of object on it will increase. Excellent. Number three, the distance between the object and the center of the planet. By increasing the distance from the center of the earth, gravitational force will decrease and the weight will decrease. Excellent. Okay, if I ask you, what is the measuring device of weight? Remember? Excellent. The measuring device of weight is a spring scale. But I will tell you, spring scale can't measure the weight of very large objects. So, how can we measure the weight of very large objects? We can measure the weight of very large objects by mathematical relation. This mathematical relation is weight equal, this is the mathematical relation, weight on earth equal mass in kilogram by 10. So we can measure the weight of large objects by mathematical relation. We can't measure it by spring scale because spring scale can measure the weight of small objects only, not the weight of large objects. So the weight of large objects, we can measure them by mathematical relation, which is weight equal mass in kilogram by 10. We will answer the problem to measure the weight of very large objects. Now we have a problem to measure the weight according to the mathematical relation that we talked about it. This problem, okay, the mass of an object on Earth's surface is 12 kilogram. Calculate the following. Letter B, we will concentrate on letter B, the object weight on the Earth. We have the mass and we want to measure the weight. Remember the mathematical relation. Excellent. The mathematical relation, weight on Earth equal mass in kilogram, excellent, by 10. Excellent. Equal, what is the mass? Yes, excellent, 12 kilogram. So 12 by 10 equal 120 Newton. 120 Newton. Don't forget Newton. It is the measuring unit of weight. Okay, don't forget Newton is the measuring unit of weight. Okay, if we have, now we'll talk about the weight on moon. If we have the weight on moon and we want to measure the weight on earth, what we should do? Okay, what should we do? We have another mathematical relation to measure the weight of object on moon or the weight of object on earth. The weight of object on earth equal weight of object on moon by 6. If we have the weight of object on moon, we can measure the weight of object on earth by easily method, by this mathematical relation, weight on earth equal the weight on moon by 6. We will answer a problem to measure the weight of object on moon. Okay. We will answer this problem that we answered it before in letter P, and we measured the weight on earth, weight equal 120 Newton. We measured it before. Now we will measure the weight of object on moon, letter C. By the mathematical relation, we will draw the triangle. triangle. Okay. Here, weight on Earth, weight on Moon. Here 6. Okay. We want to measure the weight on Moon. Okay, the weight on Moon, we will hide the weight on Moon. Weight on Moon equal weight on Earth divided 6. Weight on Earth divided 6. So weight on Moon equal weight on Earth divided 6. Weight on Earth, we answered it before, 120, 120, 120 divided 6 equal 20. Equal 20 Newton. Don't forget Newton, because we will talk, or we talked about weight. So the measuring unit is Newton. Now we have finished the first lesson in primary civics. Thank you for listening.